Welcome to Unlocking LaTeX Graphics, where we explore how to create graphics in LaTeX using TikZ and PGF plots. I'm Tammy Kolda, an applied mathematician. Today I'll show you how to recreate a diagram from Wikipedia illustrating the first isomorphism theorem, as well as a diagram from another website showing the relationship between differential equations and their Laplace transforms. These are different types of commutative diagrams. These diagrams will illustrate TikZ concepts such as nodes, edges, arrows, custom styles, node anchors, and coordinate calculations. I'll show two new things: customizing arrowheads using the arrows.meta TikZ library and changing the dash pattern of dashed lines. The videos on this channel are based on my book, Unlocking LaTeX Graphics, as well as some bonus materials. Before we start drawing, let's look at the document preamble. The full page and parskip packages are included for formatting. The hyperref package is included so that I can link the author name back to the YouTube channel. The important package is TikZ. I also load the arrows.meta TikZ library to get access to customizable arrowheads. Let's start by recreating the first isomorphism theorem diagram from Wikipedia. I'm showing what it should look like on the screen, and I'll include a link to the original diagram in the show notes. I'll start the TikZ picture environment with 3 nodes placed at specific coordinates. I've named the nodes using parentheses after calling the node command, and this allows for me to refer to them later when I'm drawing edges. Next, I'm going to find a custom style to use for nodes along the edges. This style sets the font size to be 0.7 times normal size and places the label midway along the edge. Now I'll add the edges between the nodes. So I'll go here after I've defined the nodes, and then I'll paste these edges. So each edge is an arrow. One goes from G to H, the other goes from G to GF, and the last one goes from GF to H. I'm using the edge operation to draw the edges, which goes between the edges of the nodes, automatically picking good anchor points. For the dashed edge, I've used the dashed option, as you can see here, to make it dashed. Each edge has an associated label, which I'm creating using a node along the edge. I have to specify the placements. The midway part is inside the definition of the style, so I just need to specify the direction relative to the edge. So I'm using above for the first, left for the right, and below right for the third one. Each of these edges has an arrowhead at the end. I want to modify the style to make it look a little more like that original diagram I showed you. The classical TikZ right arrow is the usual default, and we're still going to use that, but I'm going to change its length and its width to make it look more like the picture we're recreating. I do this by changing the default arrowhead in the TikZ picture options. I set it using the right arrow equal, and then I say what I want it to be equal to inside curly braces. I'm using the classical TikZ right arrow, which is the default, but I'm changing the length to 5 points and the width to 4 points. Let's zoom in, see what it looks like right now, and how it changes when I recompile. By default, the dashes are fairly short, but in the original diagram, they are longer. I modified the dash pattern by adding the dash pattern option after the dashed option on the edge. Again, let's zoom in and compile and see how it changes. Let's compare the final result to the original diagram from Wikipedia. I think it looks pretty good. Next, I'll recreate a diagram showing the relationship between differential equations and their Laplace transforms. I'm showing the original picture on the screen, and I'll include the link to that original picture in the show notes. There are a few notes I want to make about this picture. First, the downward arrows are not going down from the centers of the top nodes. So we need to do things somewhat manually to get those lines placed correctly. Second, the lines are aligned in that the horizontal lines start and finish at the same vertical positions, likewise for the vertical lines and their horizontal positions. We'll need to take care to get that right. I'll start by creating the TikZ picture environment and some styles. The corner style is for the nodes at the 4 corners, setting the font size, alignment, and inner padding. The EDL style is similar to the one we used before, placing the label midway along the edge. In this case, we're going to make the font italicized and footnote size, and we're going to align everything to the center. Next, I'll draw the upper line. When I compile this, we have just an arrow going from the point 0, 0 to the point 3.5, comma 0. The plus plus means no matter where I start, whether it's 0, 0 or some other point, I'm going to go 3.5 to the right. Next, I'll add the first corner node to the left end of this line. This node is using the corner style. I put it to the left of the line I just drew, and I labeled it with the label LYG. Then I'll go ahead and add another corner node to the right end. I'm going to put that right after my last point. I go ahead and paste, and it's similar to before. This time I label it FYG. Finally, we can add a node along the edge, so in the middle of this arrow. So I'll do that right after the dash dash and before the next coordinate. This is using our custom style EDL, which makes the node be midway and italicized and so on. And we're putting it above the line. Here, the above equals 3 millimeters, so the equal 3 millimeters is extra, moves the label up a bit further. So now our top line is done. Next, I'll add the downward arrow on the left end. So that's a dashed arrow. Rather than using the edge operation, I'm drawing this arrow manually so that I can control where it starts and ends. So I'm starting at the south anchor of the LYG node, as you see here. But then I'm moving 3 millimeters to the right, and that's when I start drawing. So I do my move to operation. That's this plus plus 3 millimeters, comma 0. Then the dash dash says draw a line starting from that point. Along the way, I'm placing a node to the left of the arrow with the text ODE for YT. And at the end of the arrow, I'm placing another node of type corner with the text YT. I'll do the same thing on the right side now. We start at the south anchor of the FYG node. We shift left a little bit by 3 millimeters, and then we draw down by 2.5 units, the same as we did on the other side. Along the way, I'm placing a node with the text algebraic equation YS to the right, and at the end of the arrow, I'm placing a corner node below it with the text YS. Last, we have to add the bottom horizontal arrow. This is where we need some care because it should align with the top arrow in terms of its start and end positions on the vertical axis. For the starting point, I use a coordinate calculation. The dash bar notation says to take the y coordinate from ys.west and the x coordinate from fyg.west. This gives us the correct vertical alignment for the starting point of our arrow, which is going from left to right. Then I draw the arrow left by 3.5 units, the same length as the top arrow. Along the way, I place an EDL node below the arrow with the text inverse Laplace transform. Last but not least, I'll also adjust the arrow tips on this picture. So I'll go back up here to the TikZ picture options. I'll paste adjustments to the arrow, and then we'll zoom in and see what happens before and after I compile this. So we see the arrows before, and now we see the arrows with this modification. So they're a little bit shorter. So let's compare the two diagrams side by side. I think it looks pretty good. I hope you enjoyed today's episode showing how to draw commutative diagrams. I include a link to the overleaf document I created today in the show notes. If you found this helpful or interesting, please click like or subscribe. If you have TikZ or PGF plots questions, please post them in the comments. If you want to learn more, please check out the other videos. I also have a book, Unlocking LaTeX Graphics, available for purchase at major book retailers. Thanks for watching.